Hello everyone, I am Dr. Sonali and I welcome you all to CSE Core Concepts in the series of Foundations of Compiler Construction. So in my previous video, we have been discussing about the LL1 parsing. So right from the understanding of LL1 parsing to deriving the first and the follow sets, and also we have seen one example where we have actually constructed the parsing table and along with that a parse tree for a input string. So in this video, I intend to solve one more example as to how to construct a parse tree using the LL1 parser and also to check whether the grammar is LL1 or not. So let us consider this example. So this is the grammar which is given to us. So we are going to check first of all whether it is LL1 or not. And if it is, then this is the string which is given ADB dollar. This we have to solve, right? So sorry. So this is the given string grammar. So S takes the form small a, capital A, B and B. So we have three non-terminals here, S, A and B. So let us find out the first and the follow of each of them. So to start with S, the first of S is A. We can see the first terminal which is used, that is A. Thereafter the C, for C we have two terminals, that is C and epsilon for A, and for non-terminal B we have D and epsilon. Fine. So all good as of now. So let us find out the follow sets. So since S is the start symbol, the follow of S is a dollar sign. Thereafter for A, the follow of A is actually here it is B, that is non-terminal. So the first of B except the epsilon. So the first of B is what? D. So I am adding D to the follow of A. But here B can also be an epsilon. So in case here B is an epsilon, then this small b will be the follow of A. So the follow of A is D and B. Thereafter we go for capital B. So for capital B, the follow is small b, that is there. So as of now, it's done. That is first and follow we have constructed. So based on this, let us construct the 2D parsing table. So let us come here. We have written all the non-terminals here and all the terminals, that is A, B, C, D and the dollar sign. So let us have this symbol, that let us see from first of A, S is A. So which rule is getting applied? So let us write down the rule, that is S to A, B, B. Then the first of A is C. So let's go to C and the rule is A takes the form of C. But we have also one more first of A, that is epsilon. So we have discussed that in case there is an epsilon, we are going to use the follow set to use the rule. So where is follow? At D, so and B. So at B and D we have written A takes the form epsilon. Now for B, the first of B is D. So the rule we are going to write here, B is D, and for epsilon we will follow the follow of B, that is B. So in here B we are going to write B is epsilon. Now in any of the cells we do not see any intersection of two rules, hence we can say this is an LL1 grammar, and so we can proceed to create the parse tree and parse using the stack. So as we had discussed, the stack is always initialized with the dollar sign, okay? And after the dollar sign, we are going to write the start symbol S. Now, what we want is, what is our string? Our string is what? Let us write down the string here. It is ADB dollar. So A, D, B and a dollar, right? So first we have to derive A. So in our stack we have S, dollar and S. So let us see which rule we are going to write here for A. That is this rule, but we have to write the rule in the reverse order, right? So instead of this, we will write the rule in the reverse order, that is A, B, B. Now I have started generating the parse tree. So I have written S, and here we are going to pop out A because it matches our string. So we have popped out A and now our pointer is in D, right? So S to A is being done. Now from what is the top of the stack? The top of the stack is A. So let us see what about A and D, right? Our current symbol is D. So let us see what is our A, capital A with D, that is epsilon. Okay, so we are going to replace it with epsilon. So let's say A is epsilon. So let us write down here A is epsilon. Done. Now the top of the stack is my B and we want to derive D. So we had a rule that is B to D, right? So for that rule, we are going to simply pop out B and replace it with the rule D, and we are going to pop out D, and this is done. Okay, now the top of the stack is our B, as simple as that. So simply pop out B, okay, and now our pointer is at the dollar sign and we have reached the top of the stack is the end symbol dollar. That means our tree has been parsed successfully. So always remember the steps that whenever you are given a grammar, find out the first and the follow of all the non-terminals, okay, non-terminals, then create the two-dimensional parsing table. So what is the rule? That in the two-dimensional parsing table, you write all the non-terminals and the terminals followed by a dollar sign. You find out from the first function whichever rule applies. But in case if you have a grammar like E is epsilon, first is epsilon, then you have to use the follow set for applying this rule. Then if there is no intersection of rules in any of the cell, that means that the grammar is LL1 grammar, and so you take a stack to parse. So you initialize the stack with the dollar sign and the start symbol, and you keep on looking for the string and apply the rules, grammar rules in the reverse order and pop one by one. So this is how you can perform a LL1 parsing. Now in my next video, we will solve a lot of examples. In my upcoming 2 videos, we will solve lot of examples where we will discuss that how to find out whether a grammar is LL1 grammar or not. So keep a track of this playlist and don't forget to like, share and subscribe to CSE Core Concepts. Thank you.